right, one more day with the, what's today, 27th. We're still doing the intro, and we got one more day just of like some major, yeah, I want to make sure I have the same, major, like just basic review and stuff like that. So, there is a vector is called standard position when the initial point of a vector is at the origin. Okay, so remember from yesterday, the initial point is like the starting point. So that would be the initial point of this vector. It's at the origin. And then, you okay?
Huh?
Oh, I thought you, question, sorry.
No, sorry.
Okay. So, and then, if we have a vector in standard position and we have this terminal point AB, so it's basically whatever your terminal point is, we have something called the component form of a vector. And that would be that the component is equal to basically your terminal point. Okay? And so the definition, the main definition of component form, okay, is that the ordered pair that describes the changes in the x and y values. Okay? And since the component form is only with the standard position, it kind of makes sense because your standard position starts at the origin. So that means that your initial point is always going to be, 0, 0. Okay? Then if your terminal point's the AB, and you subtract the two, that would describe it. That kind of just seems logical. Okay. Everybody good and with me? Okay, and the component form is super useful because instead of doing, how did we find magnitude yesterday? Yeah, which was a pain. Now instead of doing the magnitude using that distant formula, you can use, since it starts at 0, 0, your magnitude is just going to be the square root of a squared plus b squared. So it kind of just simplifies things. Okay? And the direction angle. The direction angle, because vectors talk about direction and stuff, is where it's going from the origin, okay? And it is found by finding the tangent of theta is equal to b over a. Trig, yay. So, shall we do a little trig review with our calculators? Okay, first off, it has to be, what we're going to be doing when we're finding an angle, it has to be in a certain mode. Anybody remember what that certain mode is?
Degree.
It has to be in degree. Okay? And so you hit your mode button and you go down and say, no, I don't want radian, I want degree, and hit enter. Okay, that's fine. Okay, now, if you want to find a, side measurement, okay, then you just hit, you would just hit, the sign of, you would have the sign of whatever your theta is equal to whatever, and you just plug and chug. And you use the regular trig button. Does that ring bells? If you're looking for an angle measurement or degree, then you need to use the inverse. So your sine -1, your tangent -1. Does that ring bells? Good, I see head shaking, yay. Okay, so let's find our magnitude and direction. So, I have, for each of these vectors, it is in standard form. Okay, I forgot to add that to the notes, but we're assuming they're all in standard. That means my magnitude for R is just 7 squared plus 24 squared. Which makes it super easy because I can just do 7 squared plus 24 squared. And hey, square root is 625. Well, that's 25. Much easier than the distance formula, yes? Okay. All right, now when I want to find my direction angle, let's get green. Okay. This time when you're finding the actual angle, okay, you're going to say the tangent of the theta is equal to, hold that thought, Meyer. No, he's not. Okay, bye. Okay, so my tangent of my theta is equal to B. Well, B is 24, A is 7, and so to find out what that degree is, I just take my calculator, I do my -10, and then 24 divided by 7, and there's my degree measure. So it's going to be 70, so theta is my 73 0.74 degrees. Good? Yes? All right, so let's find my magnitude of n. So I just need to square both of them and then take the square root. So I'm going to get 9 plus 1. Can I simplify square root of 10 anymore? I'm good just like that. And then to find my theta, or my directional angle, B is going to be -1, A is going to be -3, so I'm going to say my tangent of 1/3 which gives me 18.43 degrees. Good on these? Does that make sense? Do we need to do some more? Yes? No? Okay, awesome. All right, and then we're going to talk about the component form. So, since everything was so nice and neat in the standard position and in component form, this is how we can write it into that component form so that then we can just do it and find the magnitude. Makes it easier, okay? All right, so we can write our vector into basically by just subtracting your x values and your y values. Okay, which, think about it, makes sense. We would just automatically A and B because our x1 values were 0, 0, right? Okay, so that means that if I have a vector CD and C's 3,5, D's 6,3, and I want to put it in component form, then I can just say, all right, 6 minus 3 and 3 minus 5. So that means CD vector is going to be 3, -2. That then makes it super easy to find my magnitude and my direction angle. Make sense? Because basically you're just moving it into the origin for it. Yes? All right, so our S would be what? What's my X value going to come from?
2.
What do you mean? What am I going to subtract? Yeah, we can do -2 minus 5, and then, oops, it should be S instead of B. And then we're going to have 1 minus 10. So that's going to give me -7, -9. Now, remember when we were, this to me reminds me of like slope and all the other stuff when we're doing ordered pairs. And we'd always told you, it doesn't matter which one's x1, y1, and stuff like that. It matters this time, okay? Your first point is that initial point. And so it has to be that it's terminal point minus initial point. Okay, does that make sense, kind of? All right, so let's do a couple where we're going to just then use the component form to find our magnitude and stuff. So, component form of mn. N's going to be my terminal. So we're going to have 4 minus 2 and 1 plus 9. So my component form would be 210. Perfect. Good. Okay. Magnitude then, what did we say the formula for the magnitude was? Anybody remember? Huh? The a squared plus b squared. So that would give us a squared is going to be 2. B squared is going to give us 10. Which is going to give us the square root of 104. Can I simplify that? I'm sure I can because it's even. Whoops. Oh, 4 and 26. That's definitely 1. So 4 times 26. 26 is just 2 and 13, so we're going to have 2 square root of 26. Perfect. And so our magnitude, oops. All right, directional angle, we had that the tan of theta is equal to b over a. B is 10, A is 2. And so when I plug and chug, 10 divided by 2, I get 78.69. Good. All right. Do we need to do these two? Do you feel you're all shaking your head? No, you're all okay with those? How do we do it with a graph? Pick the points. So which one's my initial point? Yep, there's my initial. So -1 and 4. And then this is my terminal. So 1, 2, 3, 4. 4, 1. Which means my vector is going to be 4 plus 1, comma, and 1 minus 4, which gives me a component form of 5, -3. Then my magnitude of C is going to be 5 squared plus -9 squared.
Never mind, I didn't get that.
Which is going to give us 25 plus 9. So square root of 34. Good. All right. And then our directional angle is just going to be negative 3/5. So negative 10, negative 3 divided by 5. Does that sound right? When you have a negative angle?
So is it? It's just the other limit.
What do you mean?
It's just like the grow, but it goes the other way, so it's even bigger.
So if we add that to 360, because your unit circle, from here to here is 360 degrees, correct? Would you agree with that? So if I have a negative 3093, that means I'm here. And so if you subtract it from the 360, that gives you to that point. Does that make sense? So we have a directional angle of 329.04. Okay? Now, what did we have to do yesterday to prove that vectors were equivalent? Remember, we had to do the distance, and then you had to do slope, so you had to do 4 calculations. Total pain in the butt, right? This is why we love component form, because we have this wonderful rule that vectors are equivalent if they have the same component form. Okay? So that means that if I say, okay, what's the component form of AB? Well, that's going to be negative 7 plus 3 and negative 2 minus 6. So I'm going to have a component form of negative 4 and negative 8. Now, do that again to CD, and I'm going to get negative 1 minus 3 and negative 9 plus 1, and I get negative 4, negative 8. Oops, sorry. Since the components are both the same, they are equivalent. And isn't that a whole heck of a lot easier than doing a whole bunch of calculations? So I can say that vector AB is equal to vector CD. Good? Okay, if I look at AB here, see, 0 minus 9 gives me 9. Negative 8 plus 2 gives me negative 6. CD, I've got 4 plus 5, that's 9. Looking good so far. But this one's 8 minus 2, that's a positive 6. Since they're not the same, AB can't be to CD. Okie dokie? Make sense? Alright, so the homework, you did hopefully 1 through 10 yesterday. So tonight you can do 11 through 20, and basically look, you're finding the magnitude, directional angle, component, and then to see if they're equivalent. So it shouldn't take you too terribly long. Deal? Questions? Comments? Tomorrow you're going to plan a spring break trip. You're going to map it out.
Wow.
Concerns? Cool? All right.